Hello friends, welcome back. Today in this video, Basic Thermodynamics, SY BTech Mechanical, Unit 3, Second Law of Thermodynamics. We are going to discuss the two aspects of a heat pump. So, heat pump is basically, now see, it can be treated as a refrigerator where the expectation, what we can say, output is the refrigerating effect, and heat pump can be also used as a heating source. Now, we will basically see the difference between a refrigerator and a heat pump. Actually, they work on the same principle, but the output is different. So, let us discuss in details. Now see, in the last video also we have discussed about heat engine, but here in heat pump, now how it acts as a refrigerator and how it acts as a heating source, what we can say. Now let us go through that. Now see, we are having the experience, or we are using many devices which work on a cycle and which maintain the temperature lower than the temperature of our atmosphere. Now, for example, if the atmospheric temperature is 35 degrees Celsius and the temperature in your refrigerator is 5 to 6 degrees Celsius. Now, what is the natural tendency of heat? Heat always flows from a higher temperature body to a lower temperature body. We have seen it in previous videos also. But if you want to do the reverse case, now that is in case of refrigerator. Now, heat transfer process occurs in nature without requiring any devices, as we have also discussed the example of the coffee. Hot coffee will get cold naturally, but the transfer of heat from a lower temperature medium to a higher temperature medium requires a special device, that is called as the refrigerator. Now see, that is the reverse process is not possible until and unless you give some input as the work and you have a cyclic device. Now, the heat pump is device, heat pump is a device which removes heat from a lower temperature reservoirs and transfers it to a higher temperature reservoirs by external work. So, this is what a heat pump. Okay. So, it is a device which removes heat from a lower temperature reservoir. Now, refrigerators are like heat engines. Now, see, like heat engines means they work opposite of heat engines on a cycle, basically on a cycle. The working fluid used in a refrigeration cycle is called as a refrigerant. The most frequently used refrigeration cycle is the vapor compression refrigeration cycle, which involves four main components, and these components are what? A compressor, a condenser, an expansion valve, and an evaporator. The refrigerant enters the compressor as a vapor and is compressed to the condensed pressure. It leaves the compressor at a relatively higher temperature and cools down in the condenser as it flows through the coils of the condenser, rejecting the heat to the surrounding medium. Now see, basically it is nothing but a cyclic device, as we have discussed. It consumes power, so that is the electrical work input, and the desired output is what? Is the refrigerating effect, what we can say. So, what we have discussed is shown in this diagram. So, this is nothing but a refrigerator working on a cyclic process, and heat is rejected to the surrounding through the condenser, and in this evaporator you get the evaporating, that is what we call as the refrigerating effect. And the diagram is drawn here. So, this is the warm environment, that is TH is greater than TL. This is the cold refrigerated space. This is the cyclic device. Now this device is this device, okay, having all these components: compressor, condenser, expansion valve and evaporator. And here the input is what? The input is work input. Okay, work is given, and that work input is given like your, what we say, the electrical work input. Now let us discuss a parameter to judge the performance of a refrigerator, what we call as the coefficient of performance. So again, in simple terms, coefficient of performance is nothing but the desired output upon the required input. What is the, and that is called as the coefficient of performance. It is the ratio. Now what is the desired output? It is the temperature at lower, that is the lower temperature than the atmospheric temperature, what we call as the QL. That is the refrigerating effect. And input is the work input, electrical work input. So in simple words, again, what is Q input? QH minus QL. So higher temperature minus lower, that is heat at higher temperature minus heat at lower temperature. And when you simplify this equation, you will get the COP of the refrigerant in this way. Now please remember, this can be greater than unity. Now let us discuss the heat pump now. Now what is the function of the heat pump? Again, heat pump's function is, the output is different here. Now see, heat pump, again, it is a cyclic device which works here on a cycle, and now the output here is heated space. See, here the desired output is this, you can see here. Okay, again I will explain this. See, the desired output is this. In refrigerator, the desired output was this. Okay, but here that is not the case. So the desired output is QH, that is the heated space. Okay, the heated space. So heating is the main output. And what is the input? Input is the W net, that is the heat input. Now the COP of a heat pump is again the same, desired output upon required input. Again, output is what? QH, and W net is the input. So you can see this is a house. So just we will first see these formulas. Again, the output is what here? The output is QH and W input. So QH minus QL. When you simplify this, you will get this formula. So if you compare the coefficient of performance of a heat pump, coefficient of a refrigerator, so it will always be, that is you will get this equation, what we can say. The, in simple words, you can say that the coefficient of heat pump is equal to the coefficient of heat pump is equal to coefficient of refrigerator plus 1, or you can say that COP of heat pump minus COP of refrigerator is equal to 1. Now in this diagram, you can see the output is this. Now you can see in winter season, the surrounding temperature is just 4 degrees Celsius. Assume the surrounding temperature is 4 degrees Celsius, but you have to heat a house or a home to 20 degrees Celsius. So this is the desired output. Okay, and for that you have to give this work input, that is the electrical work input. Okay, so this is a heat pump working on a cyclic process whose desired output is the heating of this room. Work input is this, and it is a cyclic device as we have discussed. Okay, we have discussed this. And cold outdoors. Clear? I hope now this heat pump is clear. Okay. Thank you friends. Thank you very much.